Hello, in this video I will tell you what's the isentropic speed of sound and how we come up with an isentropic speed of sound. The idea is to connect the acoustic density variations and the acoustic pressure by a linear material model. That's the basic idea of the isentropic speed of sound, and it's very inherent to acoustics. We say we have a thermodynamic equilibrium and we have a homogeneous fluid. Then the pressure, density and entropy are connected. So the pressure or the change of the pressure can be defined by two intrinsic state variables, and these are density and the entropy. So based on this formula we can say, okay, we have thermodynamic equilibrium and we have a homogeneous fluid. And furthermore, we assume that we have an isentropic thermodynamic state, and we say that the total change of the density is zero. And based on this, we then can simply reduce this equation and kind of cancel out the last term. And if cancelling out the last term, we say that this term here, the partial change of the pressure with respect to the density at a specific entropy state is the square of the isentropic speed of sound. This means if we just simply have this and we then take the state equation of the ideal gas, we can define the isentropic speed of sound as a formula, and we then simply have that the isentropic speed of sound is the square root of the isentropic exponent multiplied by the pressure divided by the density, which further populates or which further results in the square root of the isentropic exponent times R times T, which are all the parameters of the ideal gas. Ideal gas, for instance, these parameters are very material dependent. So for air, these parameters you can look up in a lookup table, and yeah, that is how we calculate the isentropic speed of sound. The isentropic speed of sound is then used in deriving wave equations. It is also the speed of how the acoustic waves are moving within the material. It is very interesting and very fundamental to acoustics. Thank you for watching this video about the isentropic speed of sound. Based on the isentropic speed of sound, we will now define in the next video the Mach number.